Okay, let's finish up this problem here. So, just to review, we've got our airplane here 5 miles up, and it's flying this way, and we want to figure out some equation. How much is theta changing with respect to this x? So how much? So every time that x changes, how much does theta change? So we just figured out that we know that tangent of theta equals 5 over x. That's just what tangent equals. So then we took the inverse tangent of both sides. So we get theta equals the inverse tangent of this. Now we have to differentiate with the chain rule. So we call it u 5 over x squared. So 1 over 1 plus u, which is 5 over x squared, times the derivative of u. So that's just 5 over negative x squared, or negative 5 over x squared. All right, and then let's and so here we kind of have it. Let's not simplify this too much. Let's give ourselves some values. Let's say what is this? So how much is theta changing with respect to x when x equals, let's do 10 miles. So this is how much theta changes with respect to x. So now all we do is we come in here and we just plug in, instead of x, we do 10. So that's 1 over 1 plus, that's a half squared. So that's 0.25 minus 5 over 10 squared. So that's just 100. So now we come up over here to our calculator and we figure out what this is. So you got 1 divided by 1.25 times, let's do a parentheses here, negative 5 divided by 100. And we see that when x equals 10 miles, d theta, so this is d theta dx equals negative 0.04, just from what we calculated. All right, so just for one more thing, let's say that this airplane is moving. Let's say this airplane is moving at 400 miles per hour towards you. So then how much at this instance, so the second that it passes 10 miles to you, how much is theta changing? Well, okay, no problemo. Just remember that this is, however we want to, this is, radians, I guess you'd be. This is changing in radians per mile. All right, so we want to figure out how much is changing with respect to you in radians per hour. So here we go. We have d theta dx times miles per hour. Well, 400 miles per hour, that's just a velocity, right? So that is miles, changing miles per hour. So this is going to give us, if we multiply this times our 400 miles per hour, we're going to end with d theta, how much theta is changing with respect to time. And that's what we want. So we're going to do negative 0.04 times 400. So negative 0.04 times 400, and that's going to equal negative 16 radians per hour, which is kind of, negative. Don't forget that negative, which is kind of a funky, a funky measurement, but that is, if the plane is traveling that fast, that's how much or how quickly theta is going to be changing, relative to this person. So you can see, really, really helpful. It's a nice, for engineering problems or anytime you're looking at an angle of theta and looking at how much it's going to change, that these are really, really useful to be able to solve that, or essential to be able to solve it, I guess. So there we go. Oh, and actually looking at this, I see one mistake that I made. So this, remember, this airplane is traveling towards you, right? So instead of this 400, this is going to be negative 400, right? So instead of this negative 16, this is going to be a positive 16. So your theta right here, which makes sense, right? If the airplane is traveling towards you, here, let me draw it up here. The airplane is traveling towards you, this theta is going to be increasing, right? Until eventually it'll be overhead, and then it'll go. So, sorry about that quick change, but this is decreasing, but this airplane is traveling towards you at 400 miles per hour. So therefore, this is going to be a positive 16 radians per hour. Sorry for the change, just wanted to clarify on that.